Hello to the IB tutors. My name is Simon, and today I will be teaching a lesson about arithmetic sequences. So we're going to start off with an example. The example being 3, 7, 11, 15, 19, and 23. From this example, we're gonna figure out what an arithmetic sequence is, right? So, in an arithmetic sequence, you have, consecutive numbers like this, right? And all of these numbers are called terms, from the first term to the k term, or to infinity in some instances. So in our case, 3 is our first term, right? So that's our first term. And 23 is our 1, 2, 3, 4, 5, 6th term, right? And so all these numbers have one thing in common, and that thing is the difference between the number before them and them, right? So in this case, the difference between each term is 4, right? Because if we subtract the second term from the first term in an arithmetic sequence, we'll find the common difference, and the difference is applicable to each 2 consecutive terms. So from 3 to 7, 7 to 11, 11 to 15, and so on. So here, as I said before, the difference is 4. So 7 minus 3 is 4, right? And so the difference will help us find the general formula, the general term. The general term. Sorry. And the general term is actually UN. So basically, any term in a sequence, finite or infinite, and that's being equal to U1 plus the difference times n minus 1, right? So in our case, U1 is equal to 3, so difference is equal to 4, and n minus 1 is dependent on which term we are looking at. So let's say we're looking at the 5th term, so U5, that would be equal to 3 plus 4 times 5 minus 1, which is 4, so 3 plus 4 times 4, which is 16, times plus 3, which is 19, so U5 is equal to 19, and it's concordant, you see, because the 5th term here is 19, and we found 19 using this general formula. So now let's look at another problem. So I'm going to switch colors to make an actual distinction between each problem, each question. So the second question would be from this sequence. So we have 16 as a first term, 11 as a second term, 6 as a third term, and so on. And we have a last term in the sequence, which is negative 64. What we're trying to find here is the number of terms in the sequence, in this finite sequence, right? So if you use kind of the difference formula, which is really not a formula, but what we will do is subtract the first term from the second term. So like this, and we get negative 5, right? So the difference is equal to negative 5, and we can plug it into the general formula. So UN is equal to the first term, which is 16, plus the difference times n minus 1, and in our case, UN is equal to negative 64, right? So 16 plus negative 5 n minus 1. So we can subtract negative 16 from both sides, and we get negative 80, right? And that's then we can divide both sides by negative 5. So can take away the negative signs, and we get 80 divided by 5, which is 16. and so n is equal to 16 plus 1, which is 17, right? So in this case, there are 17 terms in this entire sequence, from 16 being the first term and negative 64 being the 17th term. So basically, this is how you find the number of terms in a sequence. If it is finite, obviously. If it's infinite, if it's infinite, there is an infinite numbers in sequence. So next we're looking at a final problem. Let me get some more space. So this final problem is a bit more complicated, and so basically the question is, we have a sum of 3 consecutive numbers. So three consecutive number terms, actually. Let's use a terminology of sequences. In an arithmetic sequence, and the sum of these 3 consecutive terms. So the sum of the consecutive term is equal to 30. So, and the product is equal to 640. So let's ask ourselves, what does 3 consecutive terms really mean? So 3 consecutive terms is basically 3 terms that are separated by a common difference, right? So the first term, let's say, is equal to u1. The second term will be equal to u2 plus the difference. Sorry, not u2, u1. My bad. u1 plus the difference. And this third term will be equal to u1, or actually u2 plus the difference, but that will be equal to u1 plus the difference plus another difference. So u1 plus 2 differences, right? Because that's how an arithmetic sequence is defined. You have the first number and you add a difference, the same difference, a common difference each time. So basically, if we have 3 consecutive terms from which the sum is equal to 30, we have u1 plus u1 plus d plus u1 plus 2d will be equal to 30. So we can add the u1s together, so 3u1 plus and the d's together, so that's 3d's is equal to 30. And basically we can divide everything by 3. That will make everything much simpler. And so u1 is equal plus d, is equal to 10, because 30 divided by 3 is equal to 10, right? So we can also deduce that u1 is equal to 10 minus d, and d is equal to 10 minus u1. So that will be helpful later on when we look at the product of these 3 consecutive numbers. So the product of these 3 consecutive numbers would be actually u1 times u1 plus d times u1 plus 2d, right? Because they're the same 3 consecutive numbers, but obviously they're not equal to 30 with 640. So how do we do this? So if we look at this, we can see that u1 plus d right here, u1 plus d is equal to 10 actually, right? We can figure it out from the sum. So we can replace this by 10. And u1 right here is equal to 10 minus d. And although it might not seem like we're simplifying anything right here, you will see that it will be helpful later on. So we have 10 minus d, which is u1 right here, times 10. u1 plus d is equal to 10, and that's equal to u1 plus 2d. And u1, again, you can simplify, expand it actually by 10 minus d. So 10 minus d plus 2d. And sorry, it's not very legible. So that's equal to 640. And so we can simplify the last parentheses, 10 and 10 plus d, right? Because negative d plus 2d is equal to d, positive d. And so there's an identity which states that a minus b times a plus b is equal to a squared negative b squared minus b squared, sorry. And if we look at this, we're in the same situation here. A minus b is equal to times a plus b is equal to, well, 10 a squared, 10 squared minus b squared, in our case d squared, and that will be times 10, right? Because we still have the 10 right here. That's equal to 640. So we can divide both sides by 10. We get 10 squared minus d squared is equal to 64. So negative d squared is equal to 64 minus 100, which is equal to negative 36. So d squared is equal to 36, and d is equal to 6, since the square of d squared is equal to d, and the square of 36 is equal to 6. So if we go back to this thing right here, sorry, this one right here, we find that u1 is equal to 10 minus the difference, which is equal to 6, as we figured out now. That's equal to 4. So we got the first term of the 3 consecutive terms being equal to 4. So the second term, what would be the second term? It would be equal to u1 plus the difference, right, which is equal to 4 plus 6, which is equal to 10. And what would be the last term? Well, similarly, it's equal to just u2 plus the difference, so 10 plus 6, which is equal to 16. And here we go, we found the 4 consecutive terms, 4, 10, and 6. And basically that's how you solve these types of problems, right? When you have a sum of 3 consecutive terms in an arithmetic sequence, and that's equal to 30, and the product is equal to 640, you have to take this approach, which is, I think, the quickest, and you'll find a solution to such a problem. So today's lesson on arithmetic sequences is done, and I'll see you next week on geometric sequence. Thank you for your time.